Scientists based in Nigeria and Kenya have begun a major push against parasitic weeds that have spread across much of sub-Saharan Africa, causing up to $1.2 billion in damage every year to the maize and cowpea crops of tens of millions of small farmers. The project, coordinated by the Nigerian-based International Institute of Tropical Agriculture (IITA), will introduce proven technologies for fighting striga or witchweed, known by some as the violent vampire because of its bright purple color. Striga attaches itself to the roots of plants like maize and cowpea and sucks out nutrients, reducing yields and destroying entire harvest.
Striga is, it's an intractable problem in West Africa, in the maize growing areas, and also for sorghum, but it's particularly devastating for maize. And in East Africa, particularly in Kenya, as well as Tanzania and Uganda. And it's intractable because people can't move their land. So once the striga becomes established, if nothing is done, then usually what happens is farmers are forced to abandon the land or abandon crops like maize, which they find very important to their food security. So in this way, by bringing all these technologies together and putting them in new combinations, then it will allow farmers to hopefully get a combination that effectively controls striga and is something that meets their own resource and social needs.
The $9 million 4-year striga project is supported by a $6.75 million grant from the Bill and Melinda Gates Foundation to IITA. Its goal is to help 200,000 maize farmers and 50,000 cowpea farmers who work in areas with high rates of striga infestation in Kenya and Nigeria.
One of the main reasons why we picked it up is it is a challenging problem. If it is not challenged, somebody would have already done it. So we picked up problems which are extremely challenging, difficult to get results. So that's one of the main factors that attracted us. We think it's reducing striga damage or improving yield through reduction of crop loss to striga will significantly enhance crop yield and increase farmers' income and change the lives of people that we serve.
Project partners include the International Maize and Wheat Improvement Center (CIMMYT), African Agricultural Technology Foundation (AATF), International Insect Physiology and Ecology (ICIPE), and BASF Crop Protection. Some of these partners expressed the importance of partnership in this project.
Partnership is key because the problem we are dealing with is not easy. And a lot of institutions have been working on these technologies for quite some time now. And if this is well done, I think partners have a good opportunity to put their efforts together, their minds together, their acts together, and be able to deal with these problems.
The project aims to integrate delivery of striga-resistant maize and legume seeds with best agronomic technologies to fight the weed menace.
Since this striga project has one component which is based on the IRI maize technology, so hence AATF is partnering with other partners to take this technology further to other countries like in Nigeria. So this is what AATF is going to play a role in demonstrating the technology, in testing the technology, and also in taking the technology to the small-scale farmers, both in East Africa and in West Africa.
With the technology providers, with the scientists from the various CG centers like CIMMYT and IITA and ICIPE, who provide us with the technology and the technological backstop. And it's our job to produce the seed and to translate that technology and take it to the farmer.
In West Africa, IITA and partners have tested the combined use of striga-resistant maize varieties in rotation with legumes that cause witchweed seeds to germinate but fail to latch onto the host. Also in East Africa, ICIPE and partners have developed a novel cropping system known as push-pull.
The push-pull technology is a cropping system which we developed where the maize plant is intercropped with a legume, and the legume is called desmodium. Desmodium inhibits striga attachment with the root system of maize. But that desmodium is also used as a fodder, and it can be fed to to the cattle by smallholder farmers. So they not only control their striga, but also use the fodder to feed their cattle and have milk.
Organizers estimated that over 250,000 individual farmers would potentially see up to 50% higher maize yields and 100% higher cowpea yields.
Once you increase yield and productivity, first the food security among the smallholder farmers, surplus go to the urban dwellers, and then increase the income of the farmers.
The project is expected to generate an additional $8.6 million annually, a 50% higher yields for farmers across Kenya and Nigeria.